tomato seems uncomplicated. Tender skin, vivid colour, a taste we all recognize. But behind every bottle of tomato sauce lies a system far more intricate than the food itself. This is not merely a story of tomatoes passing through machines. It is a story of how modern food systems are engineered to control time, biology, risk and scale. Inside a tomato processing facility, efficiency is not defined by speed alone, but by how reliably a living ingredient can be converted into something stable, safe, and repeatable, day after day. Tomatoes do not reach factories by chance. They are harvested according to sugar levels, acidity, firmness, and precise timing, factors that determine how the fruit reacts to heat and pressure later in the process. A tomato picked too early behaves differently from one picked too late. At industrial scale, these differences matter. Once harvested, tomatoes enter a logistics network where time becomes a controlled variable. Delays increase microbial risk, alter texture, and reduce yield. From the moment tomatoes leave the field, they stop being simple produce. They become inputs within a production system. Inside the factory, tomatoes are not treated individually. They are treated as flow. Large volumes arrive at receiving bays, where the objective is not visual inspection, but stabilization of incoming conditions. Automated unloading and water plume systems move tomatoes gently, limiting impact damage while sustaining throughput. Human handling is reduced, not because people lack value, but because variability does. Water velocity, temperature, and exposure duration are carefully calibrated so tomatoes enter the next stage in a predictable state. Predictability, rather than speed, underpins large-scale food processing. Cleaning tomatoes is not about visual appeal. It is about controlling risk. Soil, plant debris, and microorganisms must be removed without damaging the skin or forcing contaminants into the flesh. Multi-stage washing systems rely on controlled agitation, filtration, and sanitization to maintain this balance.
Fresh,
Sensors
whole
continuously
red
monitor
tomatoes
water
approved.
quality.
Continue
If conditions
straight
drift,
ahead.
the system corrects itself. Here, automation replaces subjective judgment with measurable limits, ensuring hygiene is not dependent on human attention or endurance. At industrial scale, inspection cannot rely solely on human sight. Optical sorting systems evaluate each tomato in motion. Color, shape, size, and surface defects are assessed within milliseconds. Tomatoes that fail to meet processing standards are removed before they can disrupt downstream operations. This stage is not about achieving perfection. It is about protecting system stability. Removing inconsistent inputs early reduces waste, prevents mechanical strain, and preserves uniform picking behavior later. Once accepted, tomatoes are mechanically crushed to separate juice, pulp, skins, and seeds. The process must apply enough force to extract usable material, yet remain gentle enough to preserve flavor and color. These systems are designed using principles of fluid dynamics, material behavior, and thermal transfer, not culinary intuition. The objective is consistency. At this point, tomatoes cease to exist as individual fruits. They become a controlled biological material moving through pipes rather than components. Heat functions as both tool and risk. Heating tomato pulp serves to inactivate enzymes, reduce microbial load, stabilize color and viscosity. Too much heat damages flavor. Too little compromises safety. Modern processing relies on precise temperature profiles monitored continuously by sensors. Heat exchangers deliver energy only where necessary for exactly the required duration. Here, engineering decisions quietly define product form. To become sauce, tomato pulp must be concentrated. Water is removed under controlled conditions to achieve target thickness without scorching or flavor loss. Vacuum evaporation systems lower boiling points, allowing water removal at reduced temperatures. This step is less visible than cutting or frying, but it determines texture, mouthfeel, and shelf life. Sauce is not thickened by chance. It is engineered. Tomato sauce is rarely composed of tomatoes alone. Salt, sugar, herbs, or stabilizers may be introduced according to product specifications. Blending systems ensure even distribution across massive volumes. Automation ensures that a bottle filled at the start of the day tastes identical to one filled at the end. Without automated control, consistency at this scale would be impossible. Filling is among the most critical stages. Each bottle must receive the correct volume, the proper temperature, with minimal air exposure. Automated filling lines operate at speeds far beyond human capability, maintaining precision measured in fractions of a minute. Sealing follows immediately. Caps are applied with controlled torque to preserve integrity without damaging packaging. From this point forward, contamination risk must be effectively zero. After sealing, bottles undergo thermal treatment to ensure long-term stability. This process is invisible to consumers, yet it defines trust. Time, temperature, and pressure are precisely controlled to eliminate pathogens while preserving flavor. Every parameter is logged, every deviation is recorded. Food safety here is not a claim, it is a documented result. Finished bottles move into automated case packing and palletizing systems. Robots perform repetitive tasks without fatigue, ensuring stable loads and minimizing damage during transport. Storage systems organize output based on logistics logic rather than appearance. At this stage, the product shifts from manufacturing to distribution. The system's focus is no longer transformation, but protection. Despite appearances, people have not vanished from tomato factories. Their roles have changed. Instead of manual handling, workers supervise systems, maintain equipment, analyze data, and intervene when conditions fall outside expected ranges. Automation does not remove humans from production, it relocates them. The factory becomes a space where decisions matter more than motion. Automation excels at repetition and stability. It struggles with novelty. When raw material quality shifts unexpectedly, or when rare failures occur, human judgment remains essential. The system is powerful, but not self-aware. Recognizing this limitation is part of responsible engineering. Tomato sauce is a common product. The system behind it is not. Modern food processing shapes how billions experience consistency, safety, and affordability. These facilities quietly influence diets, supply chains, and resource use worldwide. They are not neutral. They reflect choices about efficiency, labor, and scale. Inside a tomato processing factory, machines perform the visible work. But behind every machine lies a decision about how food should move, how risk should be managed, and how much variability society is willing to accept. Understanding this process is not about fascination with automation. It is about recognizing how modern systems silently shape everyday life. The next time you see a bottle of tomato sauce, you are not simply seeing the product. You are seeing the outcome of thousands of engineering decisions, operating quietly in the background.